Okay, so I think the stream got disconnected previously. So let me just recap once again. So the things that we were discussing was we have got two specimens, specimen B and specimen A. Now both the specimens for both the specimens, their SPD or spectral power distribution has been given over here, right? Now the question is, so the situation is like that. These two specimens have been viewed together side by side, I mean, under two different viewing conditions or two different illuminant. This is the first condition, this is the second condition. In the first situation, both the specimen A and B together, they were viewed under illuminant D65, and in the second situation, both these specimens were viewed under illuminant type A. Now, what observation do you make from this image? That when these two specimens were viewed under illuminant D65, their appearance seemed to be same. That means both of them appear to be of the same color, hence no color difference. But as soon as we are changing the illuminant, that is the viewing condition, what happens? The two specimens are appearing to be of different color. Specimen B is becoming more redder and specimen A appears to be of blue type, right? So the same thing has been given in pictorial state in the previous slide, like over here. In this slide you can see that these are the two specimens, specimen A and specimen B. They are viewed under D65 lighting condition. Okay, so if they are viewed under lighting condition D65, their color appearance seem to be same. That means they appear to be of the same color. Now when you change the lighting condition, that means when you are seeing or viewing this specimen A and specimen B under lighting condition A, then you are seeing that their color is of different type. Okay, so what is essentially happening? Two objects are appearing to be of same color under one illumination condition and of different color under a different illumination condition. Now why does this happen? So in order to answer why does this happen, we need to understand what SPD really is. What is SPD? SPD is also referred to as sometimes as the fingerprint of the color. Why fingerprint? Because it uniquely defines all the properties of the colors. How? All these points, if you consider this specimen A over here, all these points define what? How much amount of light is being reflected in what wavelength. For this wavelength, this specimen A is reflecting how much amount of light. For this wavelength, specimen A is reflecting how much amount of light. For this wavelength, specimen A is reflecting how much amount of light. So similarly, this is how SPDs are created. Sorry. So this is essentially what SPD is. It is nothing but the fingerprint of the color. It uniquely describes a color. No two SPDs will be unique in nature until and unless the colors themselves are unique and the colors themselves are same. This is how SPD describes a color. But our eyes are not seeing this SPD, are they? Our eyes are not capable of understanding all these things. How do our eyes perceive color? Our eyes perceive color by three type of cone cells. What are these cone cells? One is S-type cone cell, M-type cone cell and L-type cone cell. L-type cone cell is responsible for perceiving and understanding light of red wavelength region, M-type is that of green wavelength region and S-type is that of blue wavelength region. So essentially how we perceive color is through perceiving these tri-stimulus values. Why tri-stimulus? Because our eyes have got three type of sensors. We are able to understand or define any colors in terms of these three sensory stimulations or tri-stimulus values. So on one hand, you see that SPD is uniquely defining all these properties of a color, how much amount of color is reflected at which wavelength by that particular patch. But our eyes are limited in perceiving color via means of only these three type of cone cells, isn't it? So what is essentially happening is our eyes are not always able to identify two or more colors having different SPD. This phenomenon through which our eyes are not able to uniquely identify different colors having different SPDs or spectral properties and ultimately perceives them to be of the same color, this phenomenon is known as metamerism. Okay, this phenomenon is known as metamerism. So I am repeating once again. The phenomenon through which our eyes are not able to distinguish the spectral properties of two or more colors and in turn perceives them to be of the same color or same appearance, this phenomenon is known as metamerism. So this explains why two colors which are actually different, why I am saying actually different, because their SPDs are different, that is why they are actually different. Now because our eyes are not able to distinguish these SPDs uniquely under a certain illumination condition, that is D65, that is why these two colors are appearing to be of the same nature. But as soon as we are changing the illumination condition, our eyes are able to detect that these two colors are not same and these two colors are different in nature. When this happens, that means under one illumination condition, two colors which are actually different appears to be of the same type, and in another illumination condition they appear to be different. This phenomenon is known as illuminant metameric failure. That means metamerism has not occurred. Our eyes have failed to distinguish, our eyes have failed to understand that these two colors are of the same nature. So I am repeating once again. The phenomenon where metamerism fails, under what condition? Under the condition that the illuminants are different. In this case D65, in this case A. So under one illumination condition, the two objects appears to be of the same color, while in a different illumination condition the objects appear to be of different colors. This phenomenon, when metamerism does not occur, this phenomenon is known as illuminant metameric failure. That means under different illuminants metamerism did not occur. Metamerism means that our eyes will be able to perceive two objects or two colors that are different in spectral properties as same. That is metamerism. Different SPD, yet our eyes are understanding it to be same. But when this does not happen under two different illumination conditions, this phenomenon is known as illuminant metameric failure. Okay.